Hey, this is Math 2, Unit 3, looking at Worksheet C, and we're talking today primarily about bisectors. And the two things we're focused on here, the bisectors, is one, an angle bisector. An angle bisector cuts an angle in half and creates two congruent angles. So it means I have an angle like this, of some sort. An angle bisector means if a line comes right in the middle and chops it up, then I have two matching or corresponding angles there. A segment bisector is the other one, and a segment bisector cuts a segment in half and creates two congruent segments. So it means I have a line, and if I say this line comes and is the bisector, then I end up with two congruent parts because it is bisecting that there. Okay? That's the idea. We're going to continue to use the same things we already talked about. Side, 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 angle, side, angle, angle, side, and then a hypotenuse leg, as well as reflexive and vertical angle properties to prove that triangles are congruent. Let's take a look at number 2. It says, given that segment BD bisects ABC. Alright, so if it's bisected, that means that this angle is going to be congruent to this angle there. Alright, and also given that angle A, this guy, is congruent to angle C, prove that ABD is congruent to, we went 2, 1, nothing, is congruent to triangle 2CBD. Alright, so looking at our proof, first of all, they copied down the statements, the given stuff, to our statements. This is what we've already said there. So this is our given. That's easy enough there. Then angle ABD is congruent to CBD. So ABD, CBD. Well, ABD is congruent to CBD. So why is that going to be true? Well, that's going to be true, we said in our opening talk here, because that is because of the angle bisector. Angle bisector is why that is there. And you can say angle bisector or definition of an angle bisector. That's why that's going to be true. And then the next one has BD, congruent to BD. That there is back to what we did before, our reflexive property of congruence. And because of that, we then said a triangle ABD is congruent to CBD, and now we have an angle side. The angle side is two angles with the non-included side, is why that is the case. So that's how we do that one. So we're adding the angle bisector, definition of angle bisector, into our idea. The other thing again that we're using is the definition of segment bisector. So that's another one you'll use in some of these other situations down here. Okay? Let's take a look at number 4. Number 4 shows us that given that E is the midpoint of DC, alright, so if it's the midpoint, that means that the distance from here to here matches the distance from here to here. That is equal there. So if I want to write that as a statement, I could say E is midpoint of DC. Okay, and that is given. Got it. And number 2, we can also say that we also have EB is congruent to AE. Alright, so EB here is congruent to AE there, and that is also given. No problem. For 2, we could say that DE is congruent to CE, and the reason for that is that because that's the midpoint, we would say that's the definition of a segment bisector. Okay, so that's going to be true there. We're not quite done yet because right now we only have a side and a side, so what I want to probably do is demonstrate that angle AEC is congruent to angle BED, and this goes back to our last lesson. This is the vertical angles, vertical angles are congruent. And then we're okay to say that triangle AEC is congruent to triangle BED because we have a side angle side. Okay, so this takes several steps to kind of put things in place, but that's the idea of what you're working on. All right. Number 6, look at one more here today. It says that first statement here, DC bisects angle CB and angle ADB. So this line here, DC bisects this angle and that angle. Okay, so that's a given. Since that is given, too, we could say that angle ACD is congruent to angle BCD. So what are we saying? We're saying that this angle here is congruent to this angle here, right? And why is that the case? That is the definition of angle bisector. Step 2, or 3, sorry, we could say that angle ADC is congruent to angle BDC. So we're saying this one is congruent to this one. Again, that is also the definition of angle bisector. I'm not done yet, I just have 2 angles. I can also then show that CD is congruent to CD, and that would be the reflexive property of congruence. And finally, we would say that triangle BDC is congruent to triangle ADC, and we would say that's so because of angle side angle. So it takes a little bit of steps there to get there, but you do finally arrive at your conclusion for why that is. But again, just the same properties are being used one after the other. Okay, hope that helps you out as you work through numbers 1, 3, and 5. Good job and good luck.